We have our reciprocal trig functions. So we're going to learn just what the parent functions look like, and then we'll use the parent function to do a few transformations. Okay, so we're going to start by looking at the graph of cosecant of x, which remember is the reciprocal of sine. I'm going to write that here. Reciprocal of sine. So when I pick my 5 key points, the angles that I've picked here are the same ones that I would normally pick for sine. So sine, we usually go from 0 to 2 pi, counting by pi over 2's. And then I also wrote down the sine value here already because I need to use those sine values in order to find my cosecant values. So for my cosecant, I'm going to actually do 1 over the sine value. 1 over, basically taking the sine value and flipping it over. So for the first one, if I do 1 over this sine value, what is 1 over 0? Undefined. Okay, for the next one, if I do 1 over this sine value, that would be 1 over 1, which is 1. For the next one, if I do 1 over the sine value, another undefined. Okay, for the fourth one, 1 over the sine value of -1 would be -1. And then for the last one, 1 over the sine value would be another undefined. So we actually have 3 places where we got an undefined. What shows up there when you have an undefined? An asymptote. Yes, it's going to be an asymptote. Okay, so we're left with just a couple of actual points. We have pi over 2, 1. And 3 pi over 2, -1. I'm going to write those down as an ordered pair here. Pi over 2, 1, and then 3 pi over 2, -1. Okay, so I'm going to start, what you're seeing in the background here, this is actually the graph of the sine function. I wanted to kind of show you cosecant on top of sine so you can kind of see how they're related. So I'm going to start by graphing the asymptote in the background. There's my green pen. Okay, one asymptote at when x is 0. Okay, another asymptote at pi. And then one last asymptote at 2 pi. And then we don't have a lot of points to graph. We can always find more points, like this 0 to pi over 2, that's really just, like if you think about it, it's like the x-axis and the y-axis on the unit circle. So we could find more than that, but I could also just show you what the graph looks like. That works too. So we have, at pi over 2, we have a point at 1. And then at 3 pi over 2, we have a point at -1. Okay, so what this one will actually look like, in between these asymptotes, you'll have one branch that's kind of a U-shape going upwards. And then on the other side, you'll have a U-shape going downwards. And that is the graph of cosecant. And this pattern would repeat over and over and over. So if you had more of the x-axis to see, you could do the same pattern again, just upwards facing you, downwards facing you, upwards facing you, downwards facing you. So this has the same period as sine. And you calculate the period the same way you would calculate it for sine. Cosecant also has asymptotes everywhere where sine equals 0. So you can see where the original sine graph was 0, you have that vertical asymptote in each of those places. So we ended up with asymptotes every pi. So how we would write that is we would say x equals, we actually don't have to list out the first one on this, we can just say pi times n. Because if n was 0, then that would be your first one at pi, or at 0. So you'd have 0, and then if n is 1, that's the one at pi. If n is 2, that's the one at 2 pi. You calculate the period the same way you calculate it for sine, which was 2 pi over the absolute value of b. Yep. Okay. We have our general form on the bottom, which just looks like every general form that we have. It just says cosecant instead of some other trig function, where a is not really an amplitude. A is a vertical stretch. B is what affects the period. What was C called again? Phase shift, right? And D is a vertical shift. Very good. We'll look at some little baby transformations on the back after we look at the parent functions. All right, looking at cosecant, or not cosecant, excuse me, looking at secant. Secant is the reciprocal of cosine. So I'm using the same key points that I would for cosine, which are the same key points that I would use for sine at 0 to 2 pi, counting by pi over 2's. And I also already wrote in the cosine values, and then we're going to use those cosine values to find the secant values, which the secant would just be 1 over the cosine value. So starting at the first one, if I do 1 over the cosine value of 1, that would be 1. Okay, if I do 1 over the cosine value of 0, we have a undefined there. 1 over the cosine value of -1 would be -1. 1 over a cosine value of 0, we'd have undefined. And then lastly, 1 over a cosine value of 1 would be 1 again. So we ended up with 2 asymptotes on this one at pi over 2 and another at 3 pi over 2. Oh, I almost wrote 3 pi over 2. It should say undefined. And then we have 3 actual points on this one. So our first point was at 0, 1. And then we have 1 at pi -1 and 2 pi +1. So I'm going to write those down as ordered pairs. 0, 1, pi -1, and 2 pi +1. And it makes the same graph as the last one. It's just you're seeing a different part of it. You're seeing like a different, instead of seeing the right side up U, upside down U, you're just seeing it a different part of that same pattern. In the background, we do have cosine already graphed, which remember cosine starts above the midline and then goes below it and then comes back above it. I'm going to start by graphing in the 2 asymptotes. One was at pi over 2, where cosine was equal to 0. And then the next one's at 3 pi over 2, where cosine also equals 0. Okay, and then we have a point at 0, 1. Another one at pi -1. And then at 2 pi, we're back at +1. Okay, so it's just a bunch of U shapes. In the middle section, you'll have an upside down U shape. Okay, and then in the left and right sections, you're actually only going to see half of the U shape. In the left section, you're only going to see the right half of the U shape. The other half would just be in the negative x values. If you had more of the axis, you could see more of it. And then on the right side, you only see the left side of the U shape. And if you had more of it, you would just see more of that U shape. Secant has asymptotes everywhere where cosine was equal to 0. Same thing like cosecant had asymptotes everywhere where sine was equal to 0. It also has the same period as cosine, and you calculate the period the same. Okay, so the period would be calculated by doing 2 pi over absolute value of b. For the asymptotes on this one, we do have to list out the first one because the first one's not at 0. So we would say x equals, the first one is pi over 2, plus or minus, and then how far apart are they? What is this distance? Pi, they're pi apart. So we would say plus or minus pi in, basically saying they're starting at pi over 2 and then every pi after that. And then on the bottom, we have just our general form, same general form as cosecant, same general form as all of the trig functions. All right, let's look at cotangent. Cotangent is going to remind you a lot of tangent. Cotangent is cosine over sine because tangent was sine over cosine. So looking at the key points on this one, I actually picked the angles from 0 to pi. 0 to pi. Okay, and I've also already written down the cosine at those angles and the sine at those angles. So to find the cotangent, we're going to do the cosine over the sine. So for the first one, if I do cosine over sine, that's 1 over 0, which is undefined. Okay, for the second one, remember when we did this on the unit circle, which part of these numbers did we only use? Just the numerators, right? Because your denominators are always going to cancel. And you can do that same trick here. Just the numerator of cosine over just the numerator of sine would become 1. Okay, for pi over 2, Cosine over sine would be 0 over 1, which is 0. Good. For negative 2 pi over 2 and then square root of 2 over 2, again, just grabbing those numerators, that would be negative square root of 2 over regular square root of 2, which would simplify to negative 1. And then very last one, negative 1 over 0. It's another undefined, right? Which, if you remember, tangent also starts with an undefined and ends with an undefined. So I ended up with 2 undefineds at the beginning and the end. And then 3 where I have actual points. I have an actual point at pi over 4, 1, pi over 2, 0, and then 3 pi over 4, negative 1. Pi over 4, 1, pi over 2, 0, and then 3 pi over 4, negative 1. Okay, and this will have the same period as the parent tangent function. Do you remember what the period of the parent tangent function was? It's not 2 pi. It's pi. It's just pi. It has the same period as that one, so it would be just pi. All right, graphing my asymptotes, I have 1 at 0. And I didn't put the tangent graph behind this just because I didn't want, there's so many like asymptotes going on with tangent and cotangent that I didn't want them to confuse anyone. Asymptote at 0, another asymptote at pi. And then in between there, we'll have a point at pi over 4, 1. Pi over 2, 0, and then 3 pi over 4, negative 1, which is similar to what tangent looks like in between its asymptotes. It has this kind of like snake through the graph like this. The only difference is tangent faces the other direction. Tangent starts on the bottom and goes to the top. So we have enough room, we could actually repeat this pattern again. This is just one cycle of it here. One cycle. We have room to make another cycle if needed. One cycle. If you made another cycle, you'd have another asymptote at 2 pi. And then that same design would repeat. You'd have a point at 0 in the middle. On the left of that, you'd have a point higher up. On the right, you'd have a point lower down. Like this. Just same pattern again. Same period as tangent. So how would we calculate the period? Pi over absolute value of b, right? Okay. The asymptotes, the first one is at 0, so we don't need to write it down, but how often do they show up? Every pi. Not every pi over 2, every pi we have another asymptote. So you would just say x equals pi times n just representing integers. 1, 2, 3, etc. We have our general form down here. All right, and then I'm going to just remind you real quick, we've officially covered all 6 of the trig functions. I'm going to remind you what they look like. So we have sine, cosine, tangent, and then the reciprocals. Reciprocal of sine is cosecant, and then secant, and then cotangent. All right. Sine is the one where it kind of starts at the midline, comes up, comes back down, and ends back here. That's sine. Okay. Cosine starts above the midline. So like if this is the midline, it's going to start up here, come down below, and then end up back over here. Okay. Tangent looks awfully similar to cotangent. It starts with a vertical asymptote, ends with a vertical asymptote, and then has a snake through in the middle. It's just facing the opposite of what cotangents was. Okay. Cosecant, remember, has vertical asymptotes everywhere where sine was equal to 0. So all of these places, cosecant will have vertical asymptotes here, here, and here. So you can draw in 3 vertical asymptotes. And then on the left side, you have the u facing upwards. On the right side, you have the u facing downwards. Okay. Secant will have vertical asymptotes everywhere where cosine was equal to 0. Okay, so it will only have 2 vertical asymptotes in the period. Okay. In the middle, you have the U shape that faces downwards, and then on the left and right, you just have that half of the U shape, half of the U shape, half of the U shape. And then cotangent looks a lot similar to tangent. It's just the little snake in the middle faces the other direction. Starts with a vertical asymptote, ends with a vertical asymptote, snakes through the other direction. We're going to do a couple of transformations on the bottom ones. A couple of transformations. We have one cosecant, one secant, one cotangent. So looking at the first one, we have 3 cosecant of theta over 2, which is basically like x over 2. What is the a value on this one? 3. What's the b value? Nope. 1/2. 1/2 is the b value. 1/2. I'm going to write it as an x instead of a theta, but it means the same thing. So we can see the a up front, and then this would be the b. Calculating the period. Cosecant, because it's a reciprocal of sine, you calculate the period the same way you do for sine, which is 2 pi over the absolute value of b. Absolute value of 1/2 is just 1/2. 2 pi divided by 1/2 turns into 4 pi. Okay. Asymptotes I'll do after I make the graph. I'm going to start by grabbing the parent function points. Remember, the x values count. It's the same thing that we do for sine. It goes from 0 to 2 pi, and it counts by pi over 2. So we'd have pi over 2 pi, 3 pi over 2. Okay. If you need to use the values from the front, you can. I also just like to remember the shape of the graph. It has 3 vertical asymptotes with one U shape facing up and one U shape facing down. So its first value would be undefined because of the vertical asymptote. Its second value would be +1. What's its third value? Undefined again, another vertical asymptote. Its fourth value is -1 because it has that point down here. And then its last value is undefined. And then I'm going to do just like I normally do to adjust my points. I'm going to just adjust using the values in the equation. Anything outside of the parentheses is going to affect the y's. So this 3 is telling me I need to do 3 times my y's. So I'm going to go down the y column, everything times 3. You can write it on the undefineds. 3 times undefined is still undefined though. And then I'm going to do the same thing for what's inside the parentheses. It's going to affect the x values. So remember, what I like to do is I like to write myself a little equation that says I take what's inside and I set it equal to a number sign, and I solve this equation for x. What would be my one step to solve for x? Multiply by 2. And that tells me exactly what I need to do to my x numbers. I need to take them and multiply by 2. So I'm going to go down the first column of my table and take all of the x's and multiply by 2. And I'm going to write out my new points. All right, 2 times 0 is still 0. 2 times pi over 2 becomes pi because the 2's cancel. 2 times pi is 2 pi. 2 times 3 pi over 2, your 2's cancel and you're left with 3 pi. And then 2 times 2 pi is 4 pi. And it should make sense that 4 pi is at the end because our period is 4 pi. And then 3 times undefined, still undefined. 3 times 1 is 3. 3 times another undefined is undefined. 3 times -1 is -3. And then we end with an undefined. Okay, so I have 3 vertical asymptotes, one at 0, one at 2 pi, and one at 4 pi. One at 0, one at 2 pi, and one at 4 pi. And then I only have 2 actual points to plot. I have pi, we're at 3. And then at 3 pi, we're at -3. And then all you got to do is just remember the general shape of this. We have a right side up facing U shape on the left, upside down U shape on the right. So take this, make a little U shape on the left. And on the right one, make another little U shape. If you wanted to, you do have room to fill in one more cycle of this. I'm going to do it in pencil just so you see what it looks like. We'd have another vertical asymptote at 6 pi. And then would the U shape on this side be facing up or down? Up, right, because this pattern would repeat again. So it would start with an up. So if you wanted to, you could finish the rest of the graph over here. And then last thing, let's write in those asymptotes. The first one's at 0, so I really don't even need to write it down. But I'm going to write down how often these show up. They show up every distance of 2 pi. So we would say x equals 2 pi times n, where n just stands for like any number after. All right, next one, secant. Put that down, please. We don't need dry erase markers right now. 2 secant of 2 pi. Okay. Do I have an a and a b? Yes. A is 2, b is 2. Feel free to draw in parentheses if you want to. Remember, theta is just like having an x value. Let's start with the period. Because it's secant, you calculate the period the same way you calculate it for cosine, which is 2 pi over the absolute value of b. And absolute value of b is 2, so 2 pi over 2 would become pi, which is going to be a shorter period than normal, because usually it's 2 pi, and now it's half of that. Okay, I'm going to fill in my x and y values. For my x's, I use the same that I would for cosine and sine, 0 to 2 pi, counting by pi over 2's. Okay, and then if you need to flip back to the front to remember what the y's are, you can, but I always remember it just has 2 vertical asymptotes, because it's the 2 places where cosine would equal 0. You have the upside down u in the middle. On the left, you have kind of a right half of the branch, and then on the right, you have a left half of the branch. Okay. So if we had to pick a number for it to start with, it's going to start at +1. And then what's the next value? We're on the back, or we're on the bottom. There you go. Let's go ahead and fill in. We've already filled in this part. I don't know why y'all were holding hands, but go ahead and fill in your x values. All right, we start with 1, and then what do we have after that? Undefined. And then we have -1, and then after that, we did our -1. After that, undefined again, and then back up here to +1. Okay, looking at how the a and b are going to affect my numbers, anything not in the parentheses is going to affect your y's. So this 2 is telling me I need to do 2 times the y's. I'm going to go back down to my table. All of my y's are times 2. You can write it on the undefineds, although it's still undefined. And then if I go look at what's inside the parentheses, that's what's going to affect my x's. But remember, it's kind of backwards, so I always write an equation. 2x, theta is just x, equals a number sign. And then we're going to solve for x. What would be my one step to solve for x? Divide by 2. That's telling me we need to take all those numbers and divide by 2. Since a bunch of them are fractions, what's mathematically equivalent to dividing by 2? Multiplying by 1/2. So you can also do your numbers times 1/2. So I'm going to go down the x column, my numbers, everything times 1/2. And then I'm going to fill in my new points. 1/2 of 0 is still 0. 1/2 of pi over 2 becomes pi over 4. 1/2 of pi is pi divided by 2. 1/2 of 3 pi over 2 becomes 3 pi over 4. And then 1/2 of 2 pi becomes pi. And then working on my new y's, 2 times 1 is 2. 2 times undefined is still undefined. 2 times -1 is -2. And then we have undefined, and we end with a +2. So So two places where we have vertical asymptotes at pi over 4 and 3 pi over 4. Pi over 4 and 3 pi over 4. And then we have a few points. We have one at 0, 2. Another at pi over 2, we're at negative 2. And then at pi, we're at positive 2. And then I'm just going to recopy down kind of the general shape of this function. In the middle, you have that upside down U shape. Okay. On the right side, you have just part of a branch. On the left side, you have just part of the branch. This is one cycle. You can make more cycles if you want to. You can basically see how often the asymptotes show up. You'd have another one at 5 pi over 4, another one at 7 pi over 4, another one at 9 pi over 4. And then you just kind of end up with those same U shapes. So you'd have right side up U, and then upside down U. And then on this side, you'd have right side up U. So when we graph it, we usually just make one cycle, but that pattern does repeat over and over and over. Even over here, you could literally draw in the rest of this U. There's room for that. Okay, so for the asymptotes, the first one didn't start at 0, so I'm going to write it down. The first one was at pi over 4. And then how often do they show up? What is this distance here? That's the distance of pi over 2, right? So I'm going to say plus or minus pi over 2 in okay, and then very last one is the cotangent. 1/2 times the cotangent of theta over 3. What's the a value on this one? 1/2. What's the b value? 1/3, right. I'm going to write it separate. 1/3. I'm also going to switch that theta to an x, although it's the same thing. A, b. Okay, for my x values, remember this was the one that was different. We didn't go from 0 to 2 pi. We went to 0 to pi, and we counted by pi over 4s. So the first thing you would have is 1 pi over 4. And then you'd have 2 pi over 4, but 2 pi over 4 just reduces to pi over, oops, sorry, that should be pi over 4 at the beginning. Pi over 4. And then 2 pi over 4 turns into pi over 2. And then 3 pi over 4 doesn't reduce, and then pi at the end. And then just remembering the general shape of the graph, this one starts and ends with an asymptote, just like tangent. And then you have a snake starting from the left and going down to get those 3 points. So its first number is going to be undefined, and its last number is undefined. Okay. What's its second number? Positive 1. And then we start working our way down. The middle one is 0, and the lower one is negative 1. Let's calculate the period. Remember, the period was different than it was for cosecant and secant. This one is just pi over b. And b is 1/3, so pi over 1/3 would turn into what when you divide? 3 pi. Very good. 3 pi is our period. All right, let's do some calculations. Starting with what's outside the parentheses, I have a 1/2, or excuse, yeah, 1/2 outside. So we're going to do 1/2 times the y's. So going down the y column on my table, everything times 1/2. And then looking at what's inside the parentheses for my x's, I have 1/3 x, so I'm going to take that 1/3 x. I'm going to set it equal to a number sign, and then I'm going to solve for x. What is my one step to solve for x? Multiply by 3. So that's telling me I need to do x equals 3 times my numbers. So all of my x's I'm going to multiply by 3. All right, starting with 3 times 0 is still 0. 3 times pi over 4 becomes 3 pi over 4. 3 times pi over 2 becomes 3 pi over 2. 3 times 3 pi over 4 would become 9 pi over 4. And then 3 times pi is 3 pi. And it should make sense that we end at 3 pi because that's what our period was. And then the first and last value will still be undefined. And then 1/2 times 1 is 1/2. 1/2 times 0 is still 0. And 1/2 times -1 is -1/2. So I'm going to start by drawing in the vertical asymptotes. I have 1 at 0 and 1 at 3 pi. 1 at 0 and 1 at 3 pi. Okay, now notice there's no pi over 4s on this graph, and we have a few that are in pi over 4s. Where would just 1 pi over 4 be? In the middle of 0 and pi over 2, right? So this is 1 pi over 4. This would be 2 pi over 4, and then right here is 3 pi over 4. And then 4 pi over 4 would just be pi. This would be 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, and then 9 pi over 4 is the one right after 2 pi. So I plot those points. I have 3 pi over 4. We're up at 1/2. 3 pi over 2, we're at 0. And then 9 pi over 4, we're at -1/2. So remember what this little middle part looks like. It kind of just snakes through the graph here. And then if you want, you can draw more of that on the right-hand side. I'm just going to leave it like this one is, since I'm not going to be able to fit a whole other period in that. All right, guys, and those are our reciprocal trig functions. Oh, we didn't do asymptotes. We start at 0, so we don't have to write 0, but then they show up every how much? Every 3 pi. So we would say x equals 3 pi times n. So where would the next one be? 6 pi, right? And 6 pi won't fit on our graph.